Well, thank you guys. It's really good to be here today. And I'm here to talk about the role of expertise in society today, where it's a very important part of our democracy. We don't all have time every day to solve every problem by ourselves. So who can we trust? How do we know how we can trust people? And it's a big, complicated question. I think one thing about having more data in the world today, having more openness in the way we communicate, is that we found actually that a lot of the experts aren't really very expert in the way they look at the world. They're not really very good when they try and describe the world, when they try and make predictions. We have kind of a crisis, really, of expertise, from incidents as major as the Iraq War to the financial crisis, to things as minor as who has the right forecasting model for the election. The conventional wisdom has been wrong kind of a lot. So what I thought is that we should start to have some kind of standards and some best practices for how we evaluate expertise, the opposite of expertise, which is bullshit, basically. So what this is like a scale for bullshit detection, basically. It's modeled off the terror alert system, which has now been retired, but the more you get into the red territory here, I'll describe a number of characteristics in a moment, the more worried you should be. So you go from trustworthy characteristics to things that are preferred, not always right, but usually a good sign, to those that are neutral, to avoiding and then outright rejection. So let me give you my first example here. So, for example, this notion of inside information. The government has an awful lot of it now, so it seems. But inside information is not free, actually. It comes at a price, which is there's some cost for obtaining that information. In politics, for example, it might be that you get it from a campaign operative who has an incentive for you to spin that information, to put something which isn't entirely accurate or truthful out to the public. Conversely, aggregating publicly available data, one of the great things about 538, all the information we use in our forecast model, it's all public. They're all publicly polls, publicly available economic statistics, and that did a lot better than at least one of the campaign's internal polls, even though they supposedly had a lot more access. But that's not to say there's never any use in inside information at all, but the idea of what I call insiderism, which is the fetishization of elite opinion and elite behavior, I think that's actually very, very dangerous. It moves from the presumption that inside information is better, that people, say, in Washington, D.C., have a better idea about how an election might go than the millions of actual voters who are surveyed every year all across the country. That's a bad characteristic. When people are talking about what the consensus is, what the narrative is in the Beltway, then run far, far away. Part of this is related to the notion of quote-unquote objectivity in journalism, which is very different from the way objectivity is defined in other fields. In some cases, journalistic objectivity just means that, well, you kind of repeat one side's talking points and repeat the other side's talking points and then kind of call it a day. In science, objectivity means it's more synonymous with the word truth, that the objective world is something which we all share and which none of us have monopoly on. So we have to kind of fart around, perform experiments, and get some things right and some things wrong, and build hypotheses and run tests and make predictions to see if our subjective view of reality corresponds to the shared objective world. And you kind of merge toward consensus in the end. But it does require synthesis and analysis, not just kind of repeating what different sides' arguments might be. So when someone kind of shows you what their thought process is, not just relying on expert quotes, but shows you how they're thinking through a problem, that truth-seeking behavior is important. Another lesson here, I think, by the way, is that just like kind of in the court of law, where if someone begins to lie about little things, they often are lying about bigger things as well. I think we should think about credibility in this way as well. I looked at the case, for example, of Jonah Lehrer, the author who was later demonstrated to have plagiarized and fabricated Bob Dylan quotes and many other things. Even before that was revealed, he was a guy who would take maybe an academic paper or a complex scientific hypothesis and oversimplify it at first, right? And then kind of misrepresent it a little bit. So is it lying? Well, maybe not exactly, but he's kind of taking something and building a narrative that isn't exactly accurate, not exactly truth-seeking. And then later it's revealed that actually he's doing things that are much worse than that. I think people who demonstrate that they're not all that interested in conveying information accurately, that they want to create a narrative about a campaign or something else, be wary of that type of behavior. So avoid it. So moving from kind of journalist into academia, I have a somewhat higher opinion, I suppose, but there are still some issues here as well. So how about, for example, the idea of academic peer review? Well, I put it in this neutral category because if you look at studies of peer-reviewed papers, then if you, for example, give the same paper to the same reviewer, there's not very high consistency on what is deemed a worthy of publication result and what might not be. Also, academic peer review creates barriers, creates more cost disseminating information to the public. So it does probably filter out some bad research, but it also means you're going to spend a long time, maybe a year or a year and a half, submitting and resubmitting this journal article. It might mean that if you have a paper that kind of tells a better story, tells a better narrative, then it might get published, whereas one that's kind of messy, like science often is, might get rejected instead. So I don't know. I think maybe if you had blogs replacing academic journals, say, here's an experiment I ran today, maybe it's interesting, maybe not, but we're disclosing this data to the public and building the public's set of resources. In contrast to peer review, again, not a terrible thing, but something that has positives and negatives. This idea of scientific consensus, I think, is a strong point of view. And consensus is something that emerges over time, not all at once. As ideas are synthesized and debated, you have a paper that usually makes an overclaim of something, then someone else corrects that, and you kind of gradually merge toward the truth. It takes a while. It's not perfect. The reason being there can be groupthink in science, just like in other fields. It can be a little slow-moving, so sometimes you have a big paradigm shift that's catching up with things that the community should have discovered many years ago, but it's a pretty good process overall as compared to a lot of ways that we have to accumulate expertise and knowledge. So the next one, this one is not necessarily a contrast so much or juxtaposition as much as two different things which are valuable. One of them is getting at the idea of transparency. Academia is often pretty good in this realm where people will share their data sets. I have to say, I've tried not to make everything I talk about here something to make myself look good. We're 538, our website. We're semi-transparent in disclosing our code. We don't disclose our code. We disclose the reasoning behind it. But transparency is a good thing. At the same time, also looking at people's incentives are important. I'll talk about markets in a moment. They're one way to create better incentives to be true and accurate. There was a new paper out recently, by the way, that said, we examined some conclusions about some of the mistruths that political partisans believe. So, for example, a lot of people think, for instance, that the deficit went up under Clinton if they're Republicans, or they think that inflation went up under Reagan if they're Democrats, both of which are patently untrue. But what this paper found is that if you actually give people a financial incentive, say, hey, we'll give you $5 if you get the answer right, then magically their partisan beliefs disappeared in some cases. They were actually more accurate and more truthful. So part of what we want to do as a society is find ways to make bullshit costlier, basically. And you can do it with carrots, meaning you can actually give people money like markets might, or with sticks, and that means I think sometimes you do have to critique people and criticize people who are leading you astray and who probably ought to know better a lot of the time. So how do I rank these two things, by the way? Well, in theory, if you know someone's incentives are well aligned, then maybe you don't need them to disclose everything. You can trust them, but we often don't know what someone's incentives are unless they're kind of transparent about what their ideas and what their issues and what their incentives are. Market-based approaches. So markets are very useful because they combine two useful things that I've talked about here already, one of which is these incentive problems where you put money on the line in making your prediction. And the other one is that you do have a means to aggregate predictions and ideas together. So I'm a fan of markets and market-like mechanisms in a lot of different fields. At the same time, one of the reasons markets work is because people have an incentive to trade because they think someone else is wrong. They think that someone else has made a bad forecast, a bad prediction, undervalues or overvalues a certain good. You need disagreement to have markets make any sense whatsoever. Markets can't, by definition, be perfectly efficient or no one would trade. The market wouldn't exist. So while markets are good, having a healthy skepticism of markets being perfect is also important. Worshipping markets and saying, well, the market assigns a price for this mortgage-backed security to be X, therefore it must be accurate, that can get you in a lot of trouble. Markets are a good mechanism, but not something that can get us in trouble the minute we think that they're without any flaw whatsoever. So some of you are billing yourselves as data scientists. You might work in the public sector or the private sector, so you hear a lot of talk about big data today, and so here's one more contrast. Big data is often just meant to use the volume of information in the world, so you collect X number of observations. You know, it's usually not a bad thing to have a larger sample size. It's usually a good thing, although if you're a hack, it gives you more ways to get yourself in trouble and cherry-pick data, but you know, a decent thing. But what's more important is robust data. And what makes data robust is more than just the size of your data set. It's also, is the data quality controlled? People talk every month about the unemployment numbers. We had a decent number come out today, for example, 175,000 jobs, I think. You guys might know the margin of error on that number is about plus or minus 150,000 jobs, right? Literally, if you had the margin of error like you do in a poll, it could be anywhere from about 20,000 jobs to 300,000 once that number is revised repeatedly over time and we get a more accurate estimate down the road. So the economic data might be big, a lot of variables, but not always very robust. Because it is easy to go wrong in analysis, because your choice of variable might change your results quite a bit, then the best thing that a data scientist can do who is being truth-seeking is to do some kind of sensitivity analysis, which is basically just saying, hey, look, if I change my assumptions, if I change what variable I use, then how much do my results change? If the answer is they don't change very much, then that's a very, very trustworthy characteristic. One thing about 538, for example, is that we weren't the only site by any means at all to have made the same type of forecast, that all kinds of competitors and friends of ours who use similar approaches or slightly different approaches, they would basically call the same states for the same candidates, so you had robustness. It wasn't that sensitive to the assumptions you made in your model instead. Sometimes you might find that your choices do make a lot of difference, then you have to defend and explain those. But a lot of times you have some model in a vacuum, kind of an ad hoc approach with no real defense of why this is the right way to go. Someone who's being honest with you should say, look, you know, I looked at this problem in several different ways, and here's what came out under different assumptions. Let you know, is it their modeling that makes a difference, or is it really speaking to what the underlying data might say? So I'm going to fast forward through a couple of these here. And talk about a couple of kind of bigger picture conclusions. So it's a very useful thing to make predictions, to actually test your ideas. Of course, it works a lot better if you have a lot of time to demonstrate over a large sample that you actually are accurate. Often things that look great kind of in the model don't really apply very well in the real world, and vice versa. Penicillin, many other great discoveries were made essentially on accident by experimenting. At the same time, I find that people who are most successful are focused on having the right process in place. I used to play poker, for example, and the irony in playing poker is that the more fixated you are on your monetary results, it's kind of the worse of a player you become. In poker, you can play a hand exactly the right way, and your opponent catches a flush sometimes. You can also play like a donkey and get lucky yourself now and then. And poker players learn that having your skill and being focused on playing the best you can given the hand that you're dealt is something that leads to more success in the end. So I don't say ignore results. If you have a really large sample, you can compare them, but it's often a more inwardly driven approach as well. And the last one here, which to the extent you can sum everything up, I think is the most useful way to do it. You know, the bumper sticker I would have on my car if I drove, which I don't, is think probabilistically, basically. This is not, by the way, a metaphysical statement about the world, although if you look at, you know, kind of quantum mechanics, maybe the world actually is literally probabilistic. But that notwithstanding, it's a question about how much do we know relative to this big world out there. Probability is the waypoint between ignorance and knowledge, and sometimes the pundit who says, I don't know, is the one that you should trust. So thank you guys very much.